Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing Illustrative Math, Grade 8, Unit 3, Lesson 11 practice problems. Our first question here, suppose you wanted to draw the graph of the equation y equals negative 4x subtract 1. Describe the steps you would take to draw the graph. The first thing I would do is identify the slope and the y-intercept. The slope is negative 4. The y-intercept is negative 1. Make sure we're paying attention to signs because... whoopsie, sorry about that. Because this should be plus b. Subtracting a number means the b is negative. Then I would start at b. Start at the y-intercept. b is negative 1. Then look at my slope. My slope is negative 4, which means think about that as a fraction. Negative 4 is negative 4 over 1 is a fraction. So that's our rise and run. I want to rise negative 4. What does it mean to rise negative 4? It means I'm going to go down 4 and over 1. Down 4 and over 1. How would you check that the graph you drew is correct? Well, what could we do about that? We know the equation is y equals negative 4x minus 1. We go through the point 0, negative 1, so I could try plugging in, substituting 0. And see if I get out a y value of negative 1. Negative 4... plug in 0 minus 1. Negative 4 times 0 is 0. Minus 1 is negative 1. So that works. Now let's check another point. This point right here would be on my graph, especially if I did it with nice graph paper, would be the point 1, negative 5. So let's plug that in and see. If I plug in that point in here, I'll erase that just to make some space. Plug in, substitute 1 into x. Negative 4 times 1 is negative 4. Minus 1. Negative 4 subtract 1 is negative 5. Does that work? Yes, it does. Yes, that graph is correct. Okay, next question. Draw the following lines and then write an equation for each. Can I get this so that everything's fit? Sorry, that's kind of small to be able to work on it with you being able to see everything, but slope of 0 and the y-intercept is 5. The y-intercept is 5 means we're going to start right there. A slope of 0 means we rise 0 when we run 1. So rise 0, run 1. See how well I can draw this line. Totally good enough. Next we have slope of 2. Y-intercept is negative 1. Y-intercept is negative 1. I'll start there. The slope is 2. 2 is a fraction, is 2 over 1. Rise of 2, run of 1, up 2 over 1, up 2 over 1, up 2 over 1. Beautiful graph. Next, C, we have the slope is -2, and the y-intercept is +1. Y-intercept of +1, that's right there. The slope is -2, so -2/1. We go down 2/1. Whoops. Up 2/1 if we're going the other direction. Perfect. Now D, the slope is -1/2, and the y-intercept is -1. So y-intercept is -1 again. We'll start right there. Slope of -1/2, rise of 1, run of 2, going down. So down 1/2, down 1/2, down 1/2, down 1/2. Perfect. Okay, we graphed all the lines. Now we're supposed to write an equation for each one. The equation, y equals mx plus b. We know our m and we know our b. Y equals 0x plus 5. That can be simplified a little bit. 0 times anything is 0. So that part will all just be 0. So this one is just y equals 5. The next one, y equals, our slope is 2, plus b, but our intercept is -1, plus -1 means -1. Slope is -2, the y-intercept is 1. Y equals -2x, because our slope is -2, plus 1, because our intercept is +1. Last one, y equals -1/2 x, because our slope is -1/2, and our y-intercept is -1, so we add -1, and that means just subtracting 1. Okay, y equals 5, y equals 2x minus 1, y equals -2x plus 1, y equals -1/2 x plus 1. Okay, this one says write an equation for each line. This could have been designed easier to write, I think. Hopefully you can see these all right. The red one is horizontal. So it kind of looks like rise of 0, run of 1. Y equals 0x. 0/1 is just 0. What's our y-intercept? It's 4. We can simplify that to just y equals 4. Horizontal lines like this are always going to have a slope of 0, so they're going to look like this. Y equals 4, y equals a number. Our blue line here is going to be similar. The slope is 0, so 0 times x is 0. It is just going to be y equals the y-intercept, which is -2. Now the green one. This green line is vertical. Rise over run. The rise is infinity, because from here it just keeps going up infinitely. In a run of 0, infinity over 0, that doesn't even make sense. What are we going to do? Let's think about this a little bit. If we look at this red line, that's the line y equals 4. the y value here is 4, the y value here is 4, the y value here is 4, the y value here is 4. That is all the points where y equals 4. This blue one is all the points where y equals -2. For our green line, this is not going to be y equals something, because this has all the different y values, but only has one x value. What's the x value here? What's the x value here? What's the x value here? All of those x values are -1. Vertical lines are our weird case, where the equation of the line does not look like y equals something. Vertical lines are always x equals something. This green line is all the points on the graph where x equals -1. I don't really have a yellow pen, but I have close. This yellow line is also a vertical line, which means it is also going to be x equals something. The x value here is 6, the x value here is 6, the x value here is 6, the x value here is 6. That is all the points where x equals 6. Okay, that one was a little tricky, but y equals 4, y equals -2, x equals -1, x equals 6. Okay, that was our last question for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.